Welcome to a new test and teardown video. This time it's a German product called Nordmende RPS 378. This means Rundfunk-Prüfsender, so that is a radio test generator, if you translate everything, I guess. I've been looking this up on Radio Museum, and it's a mix between tubes and transistors, so that is a little bit funny. They had transistors, why did they put tubes in it? So that is a little bit funny. I find it a little bit funny how to select the different frequencies. It's all the different generators, they are based entirely on the different bands for radio receivers, obviously. So UKV. So this is the normal FM radio band, and this is the 85 to 110 megahertz. And then you go to one of the AM bands or the medium wave bands, and this is all the long wave bands. But I haven't figured out yet how you select between this and this AM and FM. So is it, then you click here and then you go to this, or can you, okay, so, but we don't want FM on this band, right? So that is a little bit, or you select this frequency band and then you can select AM. I don't know. Those are the different external modulations, I guess. You can of course also make internal frequencies, I guess, though. And that's aus, so this means mains off. And then you have the marker for the modulations, I guess, wobbler. And how much for this band. It's a little bit funny the way that everything here is organized, and this is of course the output, and it can go all the way to 80 dB just by a pot. So how is that done? That is a frequency hop. Can you pull? It looks like you can do something with that one. It also looks like you can push or pull. I don't know what that does. And the frequency dials are geared, so that is pretty cool, both of them. I think we should just power it up and see if there's something coming out of this one. Yeah, let's definitely do that. So we are ready. This is an off. Spectrum analyzer is connected. Let's just crank on mains. No current usage. 20 watts, 30 watts, 5, 30, 29. Okay, so when will we see anything? 28 watts, and it's still warming up, I guess. What? No. Frequency this. Oh, look. What is doing, why is it not stable? So this is the 100 megahertz. Ah, we got some wobbly. Can I check? Oh, this is the wobble. So if I don't, there's definitely some, and also the output is really weak. But there is at least a little bit of output. This is 100 megahertz. Yeah, look at that. So that is the output. So that means the oscillator is definitely working. So, oh, and yeah, this is modulation. So that is definitely frequency modulation, or here it was AM, and this is frequency modulation. But I don't understand this, why it's turning on and off and whatever it is doing. All right, it's at least it is a little bit alive. I need to play a little bit more with it, then I will get back. You gotta see this. This is, now I'm in the K band, and on that one, the dial goes the other way. Well, isn't that funny? It says here 6 megahertz, and then why didn't they bother to make it the other way around? That's a little bit funny. But what the heck is it doing here? The doodle funny, and I can't make this funky wobbling stuff go away, and output is just, I don't know, more than 20 or 30 dB too low. So that's definitely something with the attenuator that is blown. No matter what I turn, half of the wobble thingy here, I can't make this go away or make it stable or whatever. It is just the funky blip blop generator of whatever things. So so that's definitely funny, but whatever, it's alive and it's looking really cool. Also, let's get it. It's only a few kilos. It's not that heavy. It's just me who's getting old. The case look a lot like Storno cases. I actually thought those cases were a Storno brand, and this is the first time I see something else in this type of case. So I need to change my view on things. This is definitely not a Storno case. This is probably a standard case of some sort, because now I've seen another product inside this very special case, and I think we should. What happened here? What the? That is definitely one of those connectors I really need. So that was a great find. But where is the... Now the signal is gone. What the heck? I'm a little bit lost here. Why did the signal go away? Because I pulled this out. That's weird. Yes, I could definitely feel that I was getting electrocuted when I touched this unit. And obviously, if we measure from my earth and equipment that is actually proper earth, so this is my earth, and then I have 120 volts on ground here, and this is also chassis. So don't touch this stuff and you're gonna get electrocuted. I could feel it so badly when I touched it. It really hurt. Touching all the plastic dials here in the front, nothing is gonna happen. So when I pull this in and out, I probably put 120 volts back into the signal output, and now it's completely dead. There's no more output. And we are inside. So this is the bottom plate removed, and there's some really nice metal contacts to the ground shield, and on the rear plate I think this is like 3 coils and 3 capacitors. So there is a mains input filter, and there is actually earth in the cable, but of course not an earth, or at least not a correct earthed mains plug, so that is of course a problem. What else can I see in here? We can see some tubes, so that is pretty cool. I think it was 2 tubes and like 6 or 7 transistors in total, and that's actually all we will find in here. So where's the mains transformator? It's probably, yep, it is in here. And what else can I see? Oh, a voltage regulator tube, capacitors, and some rectifiers. Yeah, the smell is good. Selenium rectifiers as always. And this good old stuff from 1966. RPS 378, yep. That's right. Let's try and open the side panels and see if we can have a better look. The side panels off, and then I find these funny any idea what that is for? There's also another one on the other side. Maybe it's for locking more units together on a shelf so they're not gonna fall down or something like that. And this is the top view of all the internal. And we got a big variable capacitor for all the low frequencies, and that is, I believe there's another variable capacitor in here somewhere for all the higher frequencies. And obviously the different oscillators, they're probably going to be joined together in this unit, and then the output here goes somehow through this white cable. Okay, this is that will be all the different cables. So this yellow cable goes to the output attenuator. So this is a variable attenuator, and I kind of knew that I've seen this one before. If you look carefully here, you will see this is one you can buy, and it looks exactly like this, because I kind of save those kind of cool souvenirs from other projects, because they're very useful as repair tools for stuff like this. So if it is the attenuator that is broken, I can now repair this unit. So that is pretty cool to save. And that is the mains transformator, really nice and big. Power supply with some resistors and stuff for that. I had the idea I could just unscrew those screws here and take out the side panels, but that is not possible, because the side panels is actually, look at that, one solid unit. So if you want to take out the sides, you need to remove those screws and then take off the entire plate. So that is a little bit weird to see. Maybe this is a look pretty plate they mounted here or something, but why would you have those screws here? Because all they do is they just go in, see, like that. So that is a little bit weird, I think. Anyway, I'll see if there's something wrong with this ground or the attenuator here, or this output connector. Yips. Where is my signal? I took away the left side of the unit. So now we can see what's going on here. And it looks a little bit like the power supply is actually all this, and we got some connectors. I think those are connectors, because that means I can unscrew those two screws and get the whole unit. Is that? Yes, that will be connectors. Ooh, that was some very, very loose connectors. I need to remember yellow is inside like that, and then what? That's it. Okay. So they're coated, so I can't screw this up. That is pretty good. So that means, wow, that is some funny connector. Why would you make your own connectors when connectors was actually invented? That's a little bit funny. Alright, so now we can pull this apart and come get access to all the other funny things here. Exactly what I thought. So that's actually not that stupid. So now the whole unit is really, really easy to access, and all we removed was the power supply, and it can actually be out here, and we can just plug the connectors in and then still play with the unit and get access to everything. So that is not that dumb after all. And now we can see, okay, here is the frequency unit for the higher frequencies. It looks like it is entirely in that unit, but I really want to see What is in here and how is this mounted? But it's beautiful, made with feed-through capacitors or filters. That is brilliant. I thought this was a power distribution or amplifier or something like that, but look, all the different inputs here, and see the diodes and this transformator right there. So this is actually a mixer. Definitely gotta be mixing. Can't figure out how to remove that screw. Comes from inside, so how you gonna get in there? I don't know. That is not that easy. Well, look at this funny design with PCBs all over and in and out here and cables and wires and I don't know what all over the place. It's a really, I don't know, let's just build something and see how it ends kind of design, isn't it? I've got like a PCB in here as well. I don't know, what do you think about this? It's definitely not an HP. I wanted to fix the mains cable. I didn't really like the way that it looks like this. It was supposed to be in here and screwed correctly, so I opened this mains filter. And look, it's all dark. Something kind of made this. So I guess there we had some flash over, or maybe an old wire fell off and it's been punking around in here. Repaired the power supply entry. Mains entry is of course important to have it nice and stable. So this is now fixed, and of course I removed the leaky capacitors. That is really not what we want. A lot of leakage to chassis. That is not a very good idea. Also, I fixed this. I drilled a hole so I can solder this banana to the center pin of the BNC through this hole, and then I added a ground wire here, so when this one is plugged in, we'll also get a ground connection, because that was not in the design of this yesterday. And of course, when you have leaky capacitors and you have mains on your chassis and you don't see, this one was plugged in like this and I didn't see anything. So I had the idea that this metal was actually connected to chassis, but it was not. So I had like 200 volts and a lot of current available on the sensor pin, actually, because now this sensor pin is connected to chassis. And obviously what happens is this is the way you blow up your spectrum analyzer. So now my spectrum analyzer is completely dead and I need to repair that one. So yeah, that is what sucks big time. And it's also because this plug is without proper earth. So that is also like many problems here leads to the destruction of the spectrum analyzer. Also, I forgot the 10 dB attenuator I always have on my spectrum analyzer. So nothing like this can happen again. But that one I also forgot. So it was just a queue of problems adding up. So let's try and test this again and see if it works. And here we go. BNC metal to chassis. Oh, if only I did that. Well. Because I can't bother to change the mains connector. Here's what I did. I just connected a cable like this and then plug it into earth. All right. So that will be the 4 different bands, and now we got plenty of output, and the signal level is very much dependent on the frequencies, But other than that, seems like we're getting pretty good output. And here's some funny thing. This is they called it wobbling, and none of these seems to have any kind of effect on whatever is going on. But this one kind of changed its shape a little bit, but not a whole lot. See, this is the attenuation. That works fine now. And so that was said, oh yeah, we can also go AM. Yeah, that is AM. Alright, so we got AM as well. Let's have a look. Wow, sine waves. So that is working. So that is AM or no. And then this funky wobbling. So some pulses of a few hundred hertz there where it goes like tick, 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 tick. I don't know exactly what the point is. Probably it is explained in the manual, and this is some fancy-pantsy things about this is of course a tester for, radios. So maybe this is to create disturbances and see if the radio can be disturbed. It's probably what's gonna happen here. Let's see if the frequencies are accurate. So this is called ZF. So this should be 460, right? So let's have a look. Is this going to work? Of course, it's not looking super pretty, but we got 461. So, and see, this is the thing. Level is very much different. So this is the K band. This is supposed to be 10 megahertz, and it's very close to 10 megahertz. This is the M band, so then we go to 1, and let's have a look. Yeah, it's almost 1, and then the L. Okay, 0.2. Ooh, this is, wow, this is also quite accurate. So, and this one also actually also works, I think, right? So we turn this off, and then we go to ZF. No. What did I do wrong? The output is just really, really weak. No. No luck with... I don't know. Yeah, okay. Those two outputs, this signal, there is definitely signal, but it's just really, really weak. That is what it is. That can't be like it's supposed to be. See when I change the... Anyway. Yeah. It's definitely doing something, but signals are super, super low. And of course, if you then go to the other, then you're hammering like a lot more. All right. It seems to be more or less kind of working. I call it a little bit unsafe for spectrum analyzers. And definitely you need earth and stuff like that.